Okay, hello everyone. My name is Raiti Bochdani and today I'm going to share my final presentation for the CS internship program. It's a big moment for me because I have grown a lot through each step of this program, and now I would like to show you something that I really enjoyed learning, some of the latest and most powerful features in C#. This presentation covers several important features and improvements in modern C#. We will explore pattern matching and how it helps write cleaner and more readable code by simplifying type and value checks. Next, we will examine nullable reference types, a key feature designed to help prevent null-related bugs. And you will learn why nullability matters, what problems it solves, and how coding used to be before C#8 introduced this concept. We will also look at the new compiler behaviors that come with enabling nullable references, including warnings that guide developers toward writing safer code. Throughout the presentation, practical code examples and tips will help you understand and apply these features effectively. One of the most frustrating errors in C# is the null reference exception. You know that classic one, an object reference not set to an instance of an object. Before C#8, every reference type, like a string, person, or even list, could be null, and the compiler didn't care. So developers had to always remember to check for null. And if we forgot once, we get runtime error. But in C#8, something powerful was introduced, nullable reference types. This is not a new data type, it's a new way of thinking about safety. And now we can use like a string question mark. And this means the string can be null. And if we use just a string, this means it should never be null. And the best part is the compiler helps you. It gives you warning if you ignore a possible null. It tells you, hey, this might be null. And are you sure you want to use it? Why should we care so much about nullable reference types? Because they help us catch bugs earlier, not at runtime, but at compile time. And that's a huge win. And this clarity helps everyone. Here is a simple comparison. For the old way, the method signature didn't tell me anything about nulls. But for the new way, the method tells me actually what it expects. Let's go back for a second. What was life like before nullable reference types? In older versions of C#, reference types could always be null, but we had no tools to warn us. And it was easy to make mistakes, and those mistakes could crash the app. Also, when you use someone else's method, you had no idea if a null was allowed or not. That's why nullable reference types are a game changer. They give us a clear signal in the code and they make the compiler part of our team. So, how does nullable actually work in code? You write hashtag nullable enable at the top of your file or enable it in your project setting. Then the compiler starts tracking nulls. And it checks, did you assign a value before using the variable, or are you trying to return null from a method that shouldn't? Or even are you using a possibly null value without checking it first? These checks lead to yellow warnings, not red errors, but they help you fix problems before they become real. And this brings C# closer to modern languages like Kotlin or TypeScript, where nulls are handled more safely. It's a small change in your code base, but a huge shift in how you write and think about nulls. Let me show you a quick example. Here, the compiler gives a warning that the warning is variable name might be null. And this is a gentle push. It's saying, hey developer, I'm not sure if this variable is safe. Maybe check before using it. And you can fix this by adding a simple null check. Now let's talk about another powerful feature, pattern matching. Pattern matching was introduced in C#7 and has evolved with each version. It lets you match types, values, and object structures in a more elegant way. Think of it like asking, is this object a person? And if yes, can I access their age right now? And you can use patterns to match based on types, constants, properties, positions, and logical expressions like when clauses. And this helps in writing shorter, cleaner, more readable code. It works great in both object-oriented and functional styles. Now, let's talk about why pattern matching really matters in real-world coding. It's not just a shiny feature, it solves actual problems we face every day as developers. Let's imagine you're building an application that works with different types of data. Sometimes you get a person, sometimes a customer, or maybe just a null value. In the past, we'd have to write meaning if and else statements, and sometimes with typecasting. But pattern matching goes beyond just types, and you can match based on property values too. Think about modern coding. We deal with JSON, state machines, and UI components. Pattern matching helps in all of these. Instead of messy if else or long switch blocks, we now write compact and readable patterns. Okay, one of the biggest benefits of pattern matching is that it leads to cleaner and more maintainable code. Here we are checking the type and then doing a cast. So much repetition, and what if someone forgets the cast? You get a runtime error. Now let's look at one of the most powerful uses of pattern matching, switch expressions. Switch used to be very limited. You could only match constants like numbers or enum values, but now with pattern matching, a switch becomes something much richer. And this reads like a rule book. It's extremely clear what each condition means. And with switch expressions and pattern matching, your logic becomes like a decision, a table organized and expressive and easy to extend later. Now, let's step into the world of the latest version, C# 13. One of the interesting improvements here is the expanded support for the params keyword. If you have used a C# before, you probably know that params allows us to pass a variable number of arguments to a method, usually using an array, and it was useful but limited. For example, we had to wrap the values in an array, and that sometimes caused unnecessary memory allocation. But in C# 13, this limitation is being reduced. Now we can use params with more advanced types, such as something called a read-only span of T and also with a scoped ref struct. If that sounds technical, here is what it really means. It allows us to pass a group of values into methods without creating extra memory, which means the performance is better, especially in situations where speed and efficiency matter, like in a game engine, real-time systems, or high-performance computing. This change might not seem dramatic at first, but it unlocks better design choices and performance in larger systems. Another exciting feature in C# 13 is called collection expression. This is one of those features that you don't realize how useful it's until you start using it. It simplifies the way we write collections like lists and arrays. Before this feature, if you wanted to create a list of items, you had to implicitly create a new list object and then call methods to add each item to it, or you had to use curly braces inside the constructor. While this worked fine, it wasn't very clean, especially if you had to write a lot of these lines across your project. And it feels more natural, especially for developers coming from other languages like JavaScript or Python, where this kind of syntax is very common. Another powerful new feature in C# 13 is partial properties. You may already be familiar with partial classes or partial methods. These allow you to split your code across multiple files, which is great for big projects or when you work with auto-generated code. But until now, properties couldn't be split in this way. But now you can declare partial properties. This means you can define one part of a property's logic in one file and complete it in another. Let me give you a practical example. Suppose you have a property that gets generated by a tool, and later you want to customize how it behaves without touching the auto-generated file. In earlier versions, you had to either rewrite the whole thing or break best practices. But now with partial properties, you can keep the generated part. So let's take a step back and reflect on what we have learned today. First, we explored pattern matching. This is more than just a fancy way to write conditions. It changes how we express logic, and it helps us clearly say if this object looks like this, then do that. It lets us focus on what we are trying to express, not how we write it. Then we moved on to nullable reference types, which solve one of the oldest and most frustrating problems in C#, the null reference exception. Instead of waiting for our app to crash at runtime, the compiler now helps us catch these problems earlier. And it warns us and guides us to think about our data more carefully. And finally, we looked at some fresh features in C# 13, like expanded parent support, cleaner collection expressions, and partial properties. All of these features point in the same direction, making our code faster, more readable, and easier to maintain. That's what modern development is really about, not just writing code that works, but writing codes that last and a code that teams can trust. Okay, before I end, I would like to take a moment to say a special thank you to Hutan. Throughout this internship program, his support, mentorship, and kindness have been incredibly valuable to me. And he's been the kind of guide who not only shares knowledge, but also builds a confidence in others. And that's something I will always be grateful for. It's rare to meet someone who cares so deeply about others' growth and who makes time to answer questions, give feedback. Thank you, Hutan, for being such a powerful part of this journey. So this brings us to the end of my presentation. In this program, I have learned not just technical skills, but also how to think like a developer, how to face problems with patience. And I believe that's what being a good developer is all about. And that's what this internship has helped me discover in myself. Thank you for being here today. I'm excited for what comes next, and I'm carry everything I've learned here with me. Goodbye, everyone.